Hey, welcome back, you lovely lot. I'm Teacher Jess, and welcome to Geo Cafe. You guys have your cups ready? Yeah? Yeah, this one was supposed to be a shout out to cyclists. I, it's actually my husband's mug, his bikeaholic. Yeah, he's like, no, I must use the cycling cup this time. Okay, I hope everyone's doing well. So, what I was thinking about looking at this time is is not the physical geography. So the previous two times we were looking at physical geography, we were looking at the cyclones and then, or the tropical cyclones, and then we were looking at rain. So this time I thought we would look into something that is more map work related. So it's GIS and remote sensing. Up, go. Okay, so I thought I'd start by just explaining what remote sensing is in as simplified terms as possible because this isn't supposed to be like a science channel. This is geography channel. So it's just to kind of understand what remote sensing is before we look at how it's useful in geography. So remote sensing is that basically it's sensing from anything that is not on the earth. In this diagram, I like this diagram. It's very nice, very simplified. They are using a satellite. So you can see the little satellite in the corner, and that's busy picking up all of the information that it's receiving from the ground. This doesn't necessarily have to be a satellite. It can be a plane, it can be a drone, it can be various different tools that they use for remote sensing. And what will happen is that you'll have something being reflected off the ground, so some type of light spectrum being reflected off of the ground and picked up by your sensor. In this picture, we're actually seeing passive remote sensing. So, passive remote sensing, when you have the source of the light from the sun, and that gets reflected off of the ground or whatever you're busy observing, and the sensor picks it up. Active remote sensing is when the sensor releases the signal and then that gets bounced back again, kind of like a bat falling out into darkness. There. So that's just the basics of remote sensing. Remote sensing, the types of information that we get depends um, on the need. So let's just take a look at these work. There we go. At the different types of resolution. So spatial resolution is probably the easiest one to understand. Spatial resolution, you can think of it as the quality of the image, as in you're just taking a photo and how clear the photo is. So this we can see like the basic one, it's a lot clearer to read. This is supposed to be high spatial resolution. I suppose it's not that clear, but it's much clearer than the one on the right hand side, low spatial resolution. So you can see it's like got big blocks, big pixels. We can't really make out what's happening over there. So this is my low resolution and high resolution. So spatial is being able to tell apart things that are next to each other. Okay. And then we have, oh, why did that not load? There it is. Okay. And then we have spectral resolution. The spectral resolution is, so without going too much into the science of it, we have the light spectrum, we have the electromagnetic spectrum, we have this tiny little band of visible light that we can see. And then outside of that, we have all of the different types of light that we can't. And the idea of spatial resolution is that spectral resolution is how clear the different types of light is. Like I said, I don't want to go too into the science part of that because this was just. But the reason why I'm bringing this up is because when we do remote sensing, we're not only just picking up what we can see, we're also picking up things that are maybe the ultralight or the ultraviolet or the infrared spectrum. So it's just outside of our visible, and they'll maybe map that different ways, or they'll use that information. Okay. And then that finally brings me to GIS, but I didn't actually want to go into the GIS yet because there was one more type of resolution that I want to out, and that is temporal resolution. Temporal resolution is the resolution of time. Hello, welcome back. The temporal resolution is the resolution of time. So we said if spatial resolution is how clearly you can see the little pixels, the temporal resolution is how frequently you record the data, how frequently you take the information. So I thought I'd compare first Google Earth to Zoom Earth. I don't know if you guys remember Zoom Earth from when we did the tropical cyclone. So Google Earth is a very broad scope. It doesn't have a specific function. We probably use it to understand land use, to understand where places are, what different places do. So it doesn't have to actually be updated very frequently. Maybe you want to see how different places are developed. Maybe you want to find your friend's house and want to see a street view or an address, or see if you can find your car parked in the driveway. It doesn't need to be updated very frequently. But Zoom Earth is tracking current weather phenomena. That needs to be updated more frequently. I think if we look over here, if I can go back in the timestamps, yeah, it goes back about 15 minutes, which means that this information is updated every. You can kind of see it, how it moves back and adjusts a little bit. So this would have a higher temporal resolution. The images are taken more frequently, so you get a clearer view that way. And I actually want to show you another one over here. This is a very, very interesting site. Here we go. This is mapping wildfires. And if I'm not mistaken, I think it's current wildfires. Yes. Okay, delayed feed, new data. Oh, there we go. So it also gives us an idea of what the temporal resolution is. So it's already saying that this is kind of outdated and that the new information will come in the next 15 minutes. So this is fairly up to date, and this is where we have the current fires. And I like that the website overlays it with, so if you see, this is the landing page. Here you've got the fire viewer, and here you have the windy viewer. And it makes sense that they would put the two together. If you are busy fighting a fire, you want to know which way the wind is blowing. You want to know, is it going to be changing direction? Is it going to be blowing towards that dry field over there? Or is it going to be blowing towards the buffer zone that we, you need to plan your course of attack with this wildfire. So this was just a nice example of the different importance of temporal resolution. This would be completely useless if it was updated as frequently as Google Earth, every few months or every few years. The people would be having a very bad time with the wildfires. So then the next thing that I want to introduce you to is GIS. The GIS is a topic that we start to look at in grade 10. It's the Geographic Information System. So what that means is we are taking the information from the remote sensing and we are mapping it in a way that is useful for us. It's a far more modern technologically savvy way of mapping, and it's kind of moving away from those old school maps. Not that the old school maps aren't still very important and very relevant, but this is just keeping it a bit more up to date. So the one place that I like to start, you'll see I've got two different pieces of information over here. So I've got raster data and vector data. The place where I like to start when I'm introducing GIS is understanding that we have two different ways of presenting the data that we're looking at or mapping. So you can see on the right-hand side that it's layered, that all of the information kind of builds over each other, and we'll look at more examples of that. So raster data is information that is presented in pixels, basically in pixels. So if you look at the definition, they'll say in rows and columns. It's pixels. I've got more examples. You have more examples, right? Uh, sorry, I thought I did. There we go. So here you can see that each little cell has a specific color in it, and that color kind of gives you an idea of what the picture or the map is showing you. But it's not always images. Sometimes the data can actually be information. So if we're looking at, let's say, population density, and we mapped it as red and green. I want to find an example. Okay, they kind of have elevation, but pity that you can't see the pixels, little blocks clearly. Other one quickly. Oh, here we go. Here's one. Average rainfall. Okay, so this map shows you each block and it shows you the average rainfall in that block and different colors for it. So I'm assuming that the dark blue would be more rainfall and the light blue less rainfall. So this is an example of how they're using raster data on GIS or on a map to show you something that isn't necessarily an image, but mapping the data as an. Okay, I hope what I'm saying is making sense so far. Then the other type is vector data. Vector data looks a lot less attractive, but it's a much easier for us to experiment with and use. So vector data uses three types of data: point, a line, and a polygon. We're going to take a look at them now. I'm going to go to Google Earth. Yeah, Google Earth is fine. I like using Google Earth because it's actually a very everyday example of GIS. We don't realize that this is GIS. This is taking all kinds of geographical information and putting it onto a map that gets frequently updated, that we use almost day to day. If you're looking for a restaurant, if you're looking for directions, you go and use Google Earth or Google Maps. Another example of GIS. Okay, so let's say over here we've got this hospital. We recognize a pin like this. We'll often see pins like this that represent location. So here we have a hospital, um, the sightseeing point. The camera, I think it's like a tourist spot. Is another hospital. This is a university there. You can see the cap. Okay, these things that I'm busy pointing out, these are point data. So they give a specific location. And the thing to know about point data is I'm quickly going to try and zoom in. Okay. The point just stays. It is at a very specific spot, at a very specific coordinate, and it doesn't blur or pixel when you zoom in and out. So I'm going to do that again. I want you to look at the back image out, and I want you to look at the image in the background. So there's definitely a satellite image. Zooming in, and you'll see that the pixels need to load. That tells me that this background image is raster data. So it is showing pixels of, I'm assuming, different colors. And then on top of it, they've added points to show information at that location. So I can click on that point, like the University of Joburg. Please do something. Go. And you can see that there is information attached to that point. That is what we refer to as attribute data. We'll just, yeah, get to that another time. So you can assign information to a. And the next thing I want to show you, the lines. It's not very obvious, but the easiest example is the road. So we see the road over here, we see the M1. And the same thing, when I zoom in, it will reload. It usually does. Sorry, it's right. My Google Earth. Loading and I don't want. Okay. So it stays as this line throughout the whole course. And the last one I want to find is polygon. And if we actually don't think we'll, I think we'll have to create one. Perfectly fine by me, because it gives me a chance to use you to the delightful tools of Earth, and then we can also take a look at Google My Maps. I like using Google My Maps as a good way to get to know the concepts of GIS. So let's say we have, what's this? This is the race course. I'm assuming this is, yeah, here we go, a race course. So we have a race course, and that looks like a pond, some kind of a lake inside the race course. So let's just go with the race course. Let's say I wanted to measure, I'm not where the course is. Is it the brown part? I think so. Brown part, yeah. So let's say I want to measure the distance of the brown part of the track. I do have updated this. I'm not sure where all of the tools. Oh, here we go. Measure distance and area. That's where I'm going to make a little dot over there, starting point. Now I've added point data. I've added a point, and I could add information about that point if I wanted. And you can see as I move the mouse around, it's kind of dragging this line with. I'm going to add a few dots. So here I can again mention the importance of resolution. So the closer I put these dots, the more accurate it will be to the actual shape. There we go. Now, as I hover the mouse over the end, it gives me an option to close shape. What I have created so far was line data. If I click on close shape, oh, and my total distance over there, about 2 kilometers. Yeah, that makes sense. So it's nice 2K track. I'm going to click over there, close data, and you can see that the whole thing has like this white over shading. Now it has become a polygon. So it is a shape. And it gives me the area as well. So you can use this, okay, square meters, square kilometers, whatever unit you want, and you can use this for whatever purpose. That's what I want to show you. This actually gives me a good chance to show you the different types of vector data once again. So we've got the points over there, the locations, that's our point data. We have the rows over here, the yellow roads that clear up as we zoom in. See them? I think there's a train tracks over here. And then you can see these gray blocks. That's our polygons, or in this case, it's showing us buildings. So the gray blocks, these are our buildings. The yellow lines are our roads. And the little locations are our points. But I want to change this background. Here we go, base map. Have a satellite image. Again, you see how it loads block by block. That's the raster data. So pixel by pixel, if you could put it that way. Okay, fantastic. This gives me a chance to introduce you to layers. The layers is like a collection of data that I overlay onto my map. So once I've drawn and plotted a few things on here, I'll be able to show it a bit clearer. So I've got this layer over here, and I'm going to name it as the pool. Go away. Perfect. And I'm going to start by drawing a line. It's close. Click on that and I close the shape. Great, that is the pool. I'm going to call it pool 1 because it was the first pool. Cave. Great. Now I should just be able to duplicate this. I think. I would hope. Not. Okay, let's shape as is. So I can pick it up and drag it. See? Nice and useful that is. Actually, it's a pool. It needs to look different. Make it blue. That blue. Yeah, I like it. Okay, there I have my pool. I can just drag it and move it right there. Lovely. So I can see how that would look. And I said that I was going to turn the rest into a field. So let's plot out a field. Bye. Field over here. Ah. Green grass that will eventually grow on it. Wonderful. Now I can see the size and the dimensions of the shapes. Pool located over there, we can build a field of 0.28 hectares. Like, okay, that's fair. Okay, so I've got the new construction that I'm putting in over here. So let's call this new. Great. And this is all in its own layer. So if I wanted to take a look at the existing, add that as its layer. So yeah, old. must say it's quite a useful way for tracking routes. If you happen to be a runner or a cyclist or anything, and you're trying to find a nice route that you want to run along, but you don't know how far it's going to be. Let's say you have a target of doing a 5K, you can use this beforehand and first just figure out where you're going to complete your 5K. Yeah, move down. So the reason why I was just duplicating the same thing twice is because I want to show you that they're on different layers. And what that means is that I've got the base map in the background. That's the satellite image. That's what we're mapping all of this on. Then I've now created one layer for the new constructions that I do and one layer for the existing construction. Now, depending on what I'm busy with, I can always change view. So I can turn off the one layer and look at the other layer. Took off both layers, go. So this is very small scale, what we have been looking at. But I want to now show you another way that we do use remote sensing. Okay. I was reading about this hurricane, Idalia. So it hit last year, very destructive, and yet they managed to see that it was going to get worse before Florida. Florida, right? Yes. The reason why they could tell is here it is site. The reason why they could tell that it was suddenly going to get worse was because of remote. So they were tracking this hurricane as it was approaching Florida. They could track the wind speeds, they could track the humidity, the cloud cover, all of this. It's actually really amazing. Using remote sensing, you can um, monitor what is on the ground, like quite physically what is on the ground. Every type of mineral and chemical has its own what they call spectral signature. So it will record the I guess the light, the electromagnetic radiation that comes from reflected by that body, and the sensor can pick up based on the spectral signature what it is busy recording. So if it's recording um, water vapor, or plants, or soil, or anything like that, even the different types of soil. I was at a conference a while back and they explained that they use this type of remote sensing to keep an eye on the health of crop. So they were busy with this, got what they were doing, but they were tracking the trees and they were trying to see if the trees were healthy. And they found that quite a few of the trees were in distress. And the only reason why they found that was because uh, of the remote sensing. They were picking up different signatures in the trees that was a sign that they weren't getting enough water or that they were getting waterlogged. So the farmer was able to address it. And he wouldn't have been able to see it looking at the tree. They had to pick that up. Um, but anyway, I got sidetracked. So in this case, they were tracking the hurricane and they were watching its movements. So you can track the temperature of the air, of the ocean. There's a little. Let me close something. Too busy trying to show stuff at the same time. I think this one might have. video this. But on the, I think it was the 27th, yeah, 27th of August, they noticed that the Gulf over here was much hotter than they had anticipated. So, because they picked up that the ocean was so hot, they realized that the hurricane was going to pick up in energy. If you remember from the earlier session, we were looking at how tropical cyclones are fueled, and that they are fueled by this high temperature, high humidity environment. And if we have this warm gulf over here, this trapped warm water, obviously when it goes over it, it's going to pick energy. And the fact that they noticed that, they realized that this hurricane was going to get a lot stronger very quickly, and they could plan accordingly. So I think they made a note over here. Um, Somewhere in this article, somewhere in the article they mentioned that since they noticed these abnormally high temperatures and they realized that the hurricane was picking up energy, they enforced a evacuation procedure. So they made sure that it wasn't even a recommendation anymore, it was just get out. So they could evacuate these people as quickly as possible because they had this information, because they could this forecast. So I just thought that was a really interesting case study. And here's another article where they talk about how the hurricane got temporarily much worse before it hit Florida. And I absolutely love this image because you can see what we are able to map with remote sensing. So I think that this is supposed to be mapping, um, do they say, in an infrared satellite image. So this is just the heat. Is it the temperature? I believe so. I suppose that would make sense. The hurricanes are quite warm. Waters. Ah, but I thought it was a lovely image that just shows you how we can map using remote sensing. So how they used infrared to to capture the structure of this hurricane as it was busy making landfall. And you can also see how it's all concentrated around you by the eye. The eye being where the most severe weather and storm and destruction happen. It's a site. That's about. Okay, so to just recap what we've basically looked at is I've introduced you to the idea of remote sensing. We briefly looked at the importance of the different types of resolution, what they are, so how you can look at spatial resolution for a nice image, spectral resolution to be able to identify things in detail, or different types of light. So if this is recording infrared, we look over here, infrared. Oh, I hope I. Yes. So there's infrared over there, there's the spectrum. So it was able to record the different types of infrared that was being emitted by this hurricane and present that using images that, oh, using colors that we can see. We looked at GIS, so we looked at raster data and vector data. So raster data is your pixel-based image. Vector data, your dots or your points, your lines, and your polygons. So our go-to is that points are Oh, I've already closed it. So points is like a location on Google Maps, or and a line would be a road or sometimes a river, and your polygon would be a building or a lake or a field, something like that. Okay. And then we took a brief look at how we can use GIS on a general maps, and how we also use remote sensing to try and anticipate disasters and prepare for them. So one where we looked at the hurricanes, and one where we just quickly looked at the wildfires. But before we wrap up, first I want to ask any questions on your side. All of this makes sense. Learn something from this, and that maybe GIS or remote sensing isn't as much of a intimidating topic anymore. Um, and you can just at least understand how we use it, how it's used in our day-to-day lives, and it's something that is exclusive to photography. Okay. Well, I look forward to seeing you guys again next week. See what we'll chat about then. Have a lovely day. Okay. Bye.